Assalamualaikum warahmatullahi wabarakatuh. Good day everyone, it's me Nuria Arianitasya on your screen, and now you're watching my another video of Solidworks 2013 Flow Simulation tutorial. As you know from the title, in this video I'll show you how to analyze single counterflow heat exchanger using Solidworks Flow Simulation 2013. But before we start running the application, let's check it first, the data that we need. So here I've got a design of double pipe heat exchanger. When in this type of heat exchanger, we all know that it contains of annulus and inner pipe. In annulus will flows the cold fluid, and in inner pipe will flows the hot fluid. We got water as our cold fluid, and water will enter the annulus at temperature 10 degrees Celsius, and we got ethanol as our hot fluid, and ethanol will enter the inner pipe at temperature 78 degrees Celsius. The inside diameter and outside diameter of both annulus and inner pipe are based on the IPS number of double pipe tube. And this is the data of double pipe size. It has 24-inch long for its inner pipe, and it has 20-inch long for its annulus. The length of its annulus teeth are 3-inch, and the range of the teeth to the heat are 0.7 inch. So that's all the data that we need to run the application. By using the Solidworks 2013, we will know the range number of temperature that water and ethanol could reach after heat exchanging process. Now let's move to the application. We click new for make the new document. Click OK. Now we can start creating the double pipe. I choose the firm plane as the plane where I sketch the double pipe structure, and I'll sketch the same thing like this design to create the annulus and the inner pipe of the double pipe. So I'll start with the dotted line. And the first two line is for the inner pipe. This is the inside diameter, and this is the outside diameter of inner pipe, and we make these three lines equal. We insert the length of the inner pipe 24 inch. The range between the ticket line and the dotted line is the number of diameters. We divide it by 2. So this is the number of inside diameter. We divide it by 2, and we got 0.69 inch. And for outside diameter, we got outside diameter divided by 2, 0.83 inch. After we set the range, now we block it with the line. We block this space with the line. Next, we're gonna sketch the last two lines for the annulus. By the way, I'm making these little lines for making me easier to create the annulus. and we insert the length of annulus 20 inch and the other line too. (20" We insert the number of outside diameter of annulus divided by 2. We got 1.0335 inch. And the outside diameter we divided by 2, we got 1.19 inch. After we set the range, now we block it with the lines. The left side After we sketching the lines, now we'll use the revolved pose to create the annulus and the inner pipe. So the dotted line will be its axis. We click the dotted line first, and then the inner pipe and the annulus. Let's try it again. Then click OK. And our annulus and inner pipe has been served. Next, click top plane, reference geometry, and click plane. So by using this plane, we're gonna making the first T in the upside, and the number of the distance between the top plane and the plane that we create is 3 inch. We plus it with the number of the outside diameters of annulus divided by 2. So 3 inch plus 1.19 inch, we got 4.19 inch, and click OK. Then we click top plane again to create the outside diameter and inside diameter for the teeth. Sketching. We insert a number of the range between teeth to the head. 0.7, we plus it with the outside diameters of the teeth divided by 2, we got 1.89 inch. And we create the circle. The first circle is for outside diameter, and the second circle is for inside diameter. We insert the number is 2.38 inch, and for the inside diameter is 2.067 inch. Click OK. Then we click this plane, sketch, insert sketch. We click this circle and convert entries. Click the second circles and convert entries. Now we click extrude boss to create the teeth. Set it and we select up to surface. Click the surface, this is the surface, and click OK. Click extrude cut. And done. Now click top plane again, and we make the teeth in the upside. Okay, top plane again. We'll do the same thing like before. Insert sketch. Features, extrude boss, up to surface. This is the surface. And we have done. We hide the plane, hide it, and the sketch, we hide it. Now we can start to do the simulation, but before we start the simulation, we save this work first. So we can start the simulation. We name it as double pipe heat exchanger. And we can start the simulation. And we insert the flow simulation. We're creating the leads in both annulus and inner pipe. We select it in the middle of the outside diameter and inside diameter. And click OK. Click wizard to start the flow simulation. Project name, we change it into double pipe heat exchanger. Next, the temperature we change into Celsius. Next, heat conduction in solids. Click OK. Next, liquids. We select ethanol and water. Next, the materials. This is for our double pipes. We select metal and copper. Next, the temperature we change it into 30 degrees Celsius, and concentration we change to ethanol, we change 1, and water we change 0. Next, and finish. Now we can start the flow simulation. Insert the fluid subdomains. First, we set the ethanol. We change temperatures of ethanol 78 degrees Celsius, and ethanol will enter the inner pipe. Click OK. Now for water. Okay. Insert solid materials for our double pipe. Predefines metals and copper. Okay. And boundary condition. Because consider ethanol will enter the inner pipe at 0.001 kilogram per second. Thermodynamic parameters, switching it into 78 degrees Celsius, and the concentration ethanol 1, water 0. We select these leads. Ethanol will be enter this side and out from this side. Now insert boundary condition for water. We considered water will enter the annulus at 0.00 kilograms per second. Just like the ethanol, we change the temperature into 10 degrees Celsius. Ethanol 0 and water 1. And we select this. Water will enter this side. Okay. Insert boundary condition again for the outstream. Okay. And we insert surface goals. Temperature average for temperature outlet of ethanol. We change this name into temperature ethanol outlet. Insert surface goal again for temperature water outlet. And now we will insert the LMTD formula. We insert equation goals 1. The temperature of ethanol inlet minus temperature of water outlet okay. Equation goals 2. Temperature of ethanol outlet minus temperature water inlet. Okay. And equation goals 3. We'll insert the equation, the LMTD formula. Equation goals 1 minus the equation goals 2 we divide it by 2 multiply log equation goals 1 minus equation goals 2. Okay. And we click run. We'll wait until the Solidworks find the answers. And it's done. We'll see the answers. We'll select temperature ethanol outlet, temperature water outlet, and the equation goes 3 for the LMTD. So we got the answer. The red one is for ethanol outlet and the orange one is for water outlet, and the green one is for LMTD. We got the number of temperature ethanol outlet is 44.8 degrees Celsius and temperature water outlet 25.8 degrees Celsius. The iterations is 19. Now we insert the cut plots. and we select the temperature of fluid. Click OK and have done. So by the colors of the fluid we can know the temperature of it. Like the red is for 78 degree and the blue one is for 10 degrees, and the green one is for the range between 32 degrees till 40.22 degrees. And next we'll insert the flow transactions for the last step of our flow simulation. We insert the number of flow, the iteration that we got before is 19, and we select the leads, we click arrows and OK. Now we insert flow transaction for the annulus 2, our water. We insert the iteration that we got, 19, and we select this leads. Click arrows and OK. And we can apply the animation of the flow transactions. We hide the cut plots first and we play this. You can see the fluid is moving. So that's all of my video tutorials of flow simulations of Solidworks 2013 flow simulations. I'm sorry if I got much mistake. You can reply in comment section if you find my mistakes. Wassalamualaikum warahmatullahi wabarakatuh.